Welcome back, students. In this video, we will continue solving board problems. In the last video, we discussed a repeated pattern, quite often repeated in board problems, of stretching a wire and calculating the new resistance. Please go through the video. In this video, we will discuss the other patterns. The first question is, here I have indicated whatever you are seeing on top. This is the year and the question number. So the wire of resistance R is cut into three identical parts. The parts are then connected in parallel. If the equivalent resistance of this combination is R1, then the value, that is the ratio of R before cutting and R1 is, there are four options, 1 by 9, 1 by 3, 3 and 9. So this is very similar to the part 10 video. In part 10 video, we have covered a textbook problem which has a similar concept where a wire is cut into 5 parts. So if you have not watched part 10 video, kindly watch it, because there I would have elaborated in detail the procedure to solve this problem. Please check that video and come back here. Now we'll solve this problem. So now each of the wire, the cut wire has a resistance of 1 by 3, because you need to note it is cut into 3 identical parts. So each of those parts will have a resistance of R by 3. And since they are connected in parallel, the equivalent resistance, that R1, whatever is called as R1, is 1 by combinations of 1 by r dash, sorry, combination of r dash is equal to 1 by r1 plus r2 plus r3. R1 is r by 3, r2 is r by 3, r3 is also r by 3. So when you put everything and calculate, you get 1 by r, that is the combination of the new resistance. 1 by r dash is equal to 9 by r. So r by r dash is equal to 9. So you need to be a bit careful. Sometimes when you go wrong in the way you do cross multiply or something, you might get the answer as 1 by 9, which seems to be correct, but 9 is correct. So you need to be very careful when you calculate these ratios, when you cross multiply all that. So then the second question is, the electrical resistivity of three materials at 20 degrees is given below. ABC, these are three materials. One of them has 10 power 17, 44 into 10 power minus 16, 1.62 into 10 power minus 8. Classify these materials as conductor, alloy and insulator. Give one example for each and state one use of this material in an electrical appliance. So this again we have discussed in part 6, the difference between conductor, insulator and resistor. What is the purpose, what they are used for, and some common materials we have discussed in part 6 of the video. And in part 7 we have seen the typical values of resistances. Like a conductor means how much value, insulator means how much value. We have seen the typical values of this resistivity. So now applying the concepts whatever we learned from this part 6 and part 7 of this video, we will try to solve this problem. So insulators have a very high resistivity in the order of 10 power 12 to 10 power 17. So the item A is an insulator because it is having 10 power 18. Because of this high resistance only, insulators are not able to conduct electricity. Then metals have very low resistivity in the order of 10 power minus 8 to 10 power minus 6. So the C, whatever was given as C, classifies as a conductor or a metal. So metals have a very low resistivity, 10 power minus 2 to minus 6, that is C. The resistivity is something which falls, the resistivity of alloys is something which falls between alloys, sorry, it falls between the insulators and conductors. So B, whatever is listed as B, is a resistor material or a alloy. Resistor is nothing but a alloy. Okay, so how we approach solution is, A is insulator. Rubber you can give as an example. Use insulator used in current carrying wire. You have wires, inside you have copper wire and outside it is protected with the insulation sheet. So insulators can be used there. Then B, alloy, example constantan. This might appear a little bit new. In the subsequent theory classes, we will discuss in detail about this alloy constantan. For now, just understand the concept. So these are used, such alloys are used in heater element in electrical iron. Okay, because they have moderate resistance to electric current. C is metal or conductors. Example is copper. They are used in current carrying wire in an electrical circuit. Then the third question, an electrical source can supply a charge of 750 coulomb. That is maybe like a battery or whatever the source. And you are drawing a current of 15 mA means milliamperes. Find the time to which the electrical source will be discharged completely. What the question says, you have a battery, you are connecting the battery to a load, and that load is consuming at the rate of 15 milliamperes. How long will that battery can supply the voltage to the device? That's the question they are asking. So here again, this was discussed in part 2 video. The definition of electric current goes as the electric charge by time. Okay, so you have the value of current, you have the charge, you need to find the time. So I is equal to qt. T, since you have to find the time, you are going to rephrase or modify this equation such that T is equal to Q by I. Q is the charge of 750 coulombs. I, whatever they are given as milliampere, that you have to convert it to amperes. So 750 by 15 into this milli is 10 power minus 3. 15 into 10 power minus 3. Upon simplification, you get 50,000 seconds. The next question is, what is meant by resistance of a conductor? Defined in SI units. Resistance is something which opposes the flow of current. So the resistance of a conductor is the opposition to the flow of electrons or electric current inside it. The SI unit is ohms. List two factors on which the resistance of a rectangular conductor depends upon. See, this again we have discussed in one of our videos on resistance. There are 4 factors, but they are asking only for 2 factors. One and most important is the nature of the conductor. See, each material has a different kind of resistivity. Based on this material, the resistivity will change. That is one factor. Then you have the length of the conductor. How long is that conductor? And the cross-sectional area. I am giving one more factor, though only 2 are sufficient. You should not mention just the area of the conductor. The word cross-sectional area is very important. The resistance of a wire. This is a problem. The resistance of wire is 0.01 centimeters. And the resistance is of for 10 ohms. So the wire radius is 0.01 centimeter. Its resistance is 10 ohms. The resistivity of the material, that is the rho, 50 into 10 power minus 8 ohm meters. Find the length of the wire. This again we have discussed in detail in part 7 video. So this formula is what you are supposed to use now. Resistance is equal to rho into L by A. They have given all values, but you are required to find out L. So R is equal to rho into L by A. So since I need to find out the value of L, I am rearranging the equation to make it as L is equal to R into A by rho. This 0.01 centimeter I need to convert it to meter because the other unit whichever is there in the equation is in the form of meters. So I have to convert this 0.01 centimeter to meter. So 0.01 divided by 100, which is equal to 1 into 10 power minus 4 meters. Okay. So now to calculate the length, L is equal to 10. 10 is the resistance, 10 ohms. 10 into area. Since you know the radius, you are supposed to calculate the area of this circular wire or the cylindrical wire. Pi r square. Pi is 22 by 7 into this value of radius will come here divided by rho, whatever is there, 50 into 10 power minus 8. Very easily this 10 power minus 8 and this will get cancelled. And upon solving the equation, you get somewhere 0.628 meters, which is nothing but 62.8 centimeters. So now the question goes as the maximum resistance. Find the maximum resistance which can be made by using 4 resistors of 0.5 ohms each. The 4 options are given: 2, 1, 2.5, 5. So you have 4 resistors, each has 0.5 ohms. So how or what arrangement will give you maximum resistance? This we have discussed in earlier video where on resistance, so maybe part 7 or 8, where we have discussed a series arrangement gives the highest resistance possible. So it's a part 8 video. So what you need to do is you need to add all the resistances as in series. So to get the maximum resistance, add all the resistors are connected in series. That is 4 into 0.5 ohms. You're supposed to write as 0.5 plus 0.5 plus 0.5 plus 0.5, which is 4 times, is equal to 2 ohms. So one of the options is 2 ohms. The first option is the right answer. So just in as a practice, you can try this for minimum also. Like for minimum means it's a parallel connection, not a series connection. It becomes a parallel connection, and the resistance is equal to 1 by R is equal to 1 by 0.5. 4 times you have to write it. Whatever you calculate, you get is the lowest or the minimum resistance. So next video we will discuss more theory part. Bye and thank you till then.